Kate.
And we are the
Sister Scientists.
Welcome to the lab.
In this lab, we'll be exploring the most confusing and difficult science topics known to man.
Today specifically, we're going to look at some concepts like heat and density and see how they're related through a little experiment. Here are all the materials that you're going to need for an experiment like this. First, 2 clear cups. They should be the same size so that when they're touching, they meet at the right exact point. Number 2, a spoon, because we're going to be doing some stirring. Number 3, 2 different color food dyes. Today we're going to use blue and yellow so we can see what happens to the different types of water. The next thing you'll need is some kind of material like this. We took 3 playing cards and taped them together so we could have a surface in between the 2 cups that we could easily move out that was pretty thin. You'll see what this means when we actually perform the experiment. The next thing you'll need is hot water or warm water, something that's a lot different than just lukewarm or cold water. And then you'll also need cold water. This just came right out of the fridge. So we're going to use all of these materials to see how hot water and density interact.
First thing you're going to want to do is acquire the cold water. So the cold water will go into one of the cups. Emma is going to pour the cold water into the cup for us. Today we are going to be using the blue food dye with the cold water because often we associate blue with cold. So this will help me remember better. And we're going to put 3 drops of food dye into the cup. 2, 3. You can already see how the food dye is moving through the water. The next thing we're going to do is we're going to put the hot water into our cup, the same way that we did with the cold water. We're going to fill it to the brim, and then today we'll be using yellow food dye for the hot water, because often we associate warm colors like yellow and red with warm. Okay, so now we have hot water. The next thing I'll be doing is putting 3 drops of the yellow food dye into the hot water. 1, 2, 3. You can already see how the blue food dye has been diffusing through the cold water, and the yellow food dye is quickly diffusing through the hot water. The yellow food dye is going to diffuse a lot faster because the water's hot, so the particles are already moving a lot faster. Now that we have appropriately mixed our yellow food dye and our blue food dye, the next thing we're going to do is kind of a safety precaution where we're going to put a container underneath our experiment that we'll be doing. First thing we're going to do is have the hot water on the bottom, and then we will be putting the blue on top, and we're going to see what happens. The next thing you're going to want to do is take your playing cards, or whatever you're using in place of playing cards, and place it tightly on top of your cup. Here's the tricky part. You may need a parent to help you. Is you're going to flip the cup upside down. And then you're going to place this on top of the cup. A little spillage is okay. It's normal, actually. It means you're human. The next thing you're going to do is quickly, like magic, you're going to pull the playing cards from between the cups. This is the trickiest part. So watch carefully and try to repeat yourself at home. And instantaneously, the colors mix, the blue and the yellow have mixed together, and the colors of both cups are green. Interesting. Now that we've already seen what happens when you put the hot water on the bottom and the cold water on the top, we're going to see what happens when you put the hot water on the top and the cold water on the bottom. So the blue will end up going on the bottom and the yellow will end up going on the top. Emma's going to pour us the cold water again. And again, you're filling it to the brim. And you'll put 3 drops of blue dye. While I'm doing that, Emma will put the hot water into the other cup. This one will be dyed yellow again. Thank you, Emma.
You're welcome.
We put 3 drops of yellow dye. 1, 2, 3. And we'll stir to speed up the diffusion process. Again, safety precaution, we will be using the container to go on the bottom. And like I said, the blue will be going on the bottom this time. Switch things up. And the yellow will be going on the top. Again comes the tricky part. This time it's a little difficult because it's hot, so it's going to hurt your hands a little bit if you do this at home. So please be careful. We flip over the cup. And on top. Now, let's remember what happened last time. Last time we had the blue on the top and the yellow on the bottom, right? And when I removed the cards, when I removed the barrier that was between the waters, instantaneously, almost right away, the colors mixed, both cups became green, and that was it. Let's see if the same thing happens this time. No way. This time, at the bottom of the cup remained blue. And this time, the top cup remained yellow, and only the middle part where both waters touched turned green. Let's find out why.
In this first experiment, we used 2 trials to see how hot and cold water interacted and what that meant for their density and molecules. In the first trial, we put the cold water on top and the hot water on the bottom. Looking more specifically at the hot water, when you heat up water, you're actually heating up the molecules within them. By doing so, it means the molecules are moving all over the place quickly and bouncing off of one another, creating more space between the molecules. Because of that, the hot water is actually less dense. And that means that when they were put on top of each other, the less dense moved upward in rows, while the cold water, which was more dense, went to the bottom, and the two interacted to create a lovely shade of green where they balanced out. In trial 2, we put the cold water on the bottom and the hot water on top. The same rule applies, where the cold water means that the molecules are actually moving slower, where the hot water, the molecules are moving quicker, which means they're bouncing all over the place and moving very quickly. That quick movement and the thermal energy within it means that it's actually less dense than the cold water. Because it's less dense, it rises to the top and it stayed there when we put them next to each other. That's the reason the cold water stayed at the bottom and in between the two mixed to show a little bit of green where they balanced out and found where their densities led them. Now we're going to take a look at a similar experiment looking at the heat and density of air and how that affects the things around it. So what you're going to need for this experiment is a lighter or a match of some sort, something to give you a flame, a candle, a piece of paper that's coiled, which is just cutting in a circle and then cutting in the coil to kind of give it a snake effect on the paper here. We also have a pin attached to the top of the paper so that it can be connected and easily spun, so it's kind of free in the air. So we have this contraption here that's actually meant for coffee to hold it up. Or you can simply hold it up with the pin so that it's at a good distance from the candle and you can still see the same results from the experiment. So what we're really going to look at here is what happens when you heat up air and how that affects the objects around it. So what we're going to do is light this candle and then see how it affects the coiled paper above it. Let's find out what happens. In this demonstration, the candle was our source of energy. The candle caused an increase in thermal energy by heating the particles around it in the air. As the particles were heated, they expanded, causing them to be less dense. Therefore, they rose, and as they were rising in energy and in space, they moved the spinning snake. Then the hot air was then replaced with cold air. As the hot air rose, the cold air sank, and that's because the cold air had less thermal energy.
This caused the snake to spin as the air was moving.